Hello friends, welcome back. In this video, I will explain chapter number 2, acids, bases and salts. Subject science, that is chemistry part, class 10, CBSE board. So basic difference, acid and bases. Acids, the taste of acid is sour taste. Taste of base is bitter. In acid, blue litmus paper turns red. In base, red litmus paper turns blue. If we add turmeric in acid, it remains yellow as it is. But if we add turmeric to the base, it turns red. Why this is? Because turmeric contains chemical called curcumin, which remains yellow in acidic or neutral solution, but it turns red when solution is base. That's why in bases, if we add turmeric, it becomes red. Now, how to find whether given substance or given aqueous solution is acidic or basic nature? For this, you have three tests. First one, litmus solution test or litmus paper test. Second one, phenolphthalein solution test. And third one is methyl orange solution test. Here I have shown one table. In that some sample solutions are there. We have to find out whether these are acid or base. We have three indicators, that is litmus test, phenolphthalein test, methyl orange test. All these three indicators are called as olfactory indicators. Why they are called olfactory indicators? Because they change their color or become colorless or remain in same color if they get added in solution of acid or base. So now one by one we'll study HCl. As HCl is hydrochloric acid, as this is acid, here blue litmus paper turns red. If phenolphthalein solution is added to the HCl, it becomes colorless. If we add methyl orange to the HCl, the solution becomes pinkish red. H2SO4, HNO3, CH3COOH, all these are acids because blue litmus paper or blue litmus solution turns red. Phenolphthalein remains colorless. Methyl orange added, solution becomes pinkish red. They are acid in nature. Acid shows this phenomenon. Now CH3COOH, NaOH, KOH, MgOH twice, NH4OH, CaOH twice. Here from NaOH to CaOH twice. These are bases. Why? Because here red litmus paper or red litmus solution turns blue. This is first test. This is phenolphthalein solution changes from red to pink. If we add methyl orange solution to base, or if we add base to the methyl orange solution, then solution remains yellow only. So these are the criteria to find out whether given substance or solution is acid or base. Here from HCl to CH3COOH, that is acetic acid. These are acids. From NaOH to CaOH twice. 1, 2, 3, 4. These are the bases. And by memorizing this table, you can find out properties of acid and bases when they added in olfactory indicators or olfactory indicators added in that solution. They shows this type of changes in color. Thank you for watching the video. If you like it, please do share it. Subscribe channel for more such fruitful videos. Hello friends, welcome back. In this video, we will study how do acid and bases react with metal. Means if acid reacts with metal, which products are formed? If bases reacts with metal, which products are formed? That will study. First, if acid reacts with metal, the products are formed are salt and hydrogen gas. See example. Zinc, when react with sulfuric acid, zinc sulfate is formed, zinc sulfate is salt and hydrogen gas is evolved. Now, if metal reacts with base, salt plus hydrogen gas is formed. So metal NaOH is in aqueous state. Zinc, this is base, this is metal. When they react with each other, Na2ZnO2, sodium zincate. This is a salt and hydrogen gas is evolved. Means when metal reacts with acid and base, the product formed are salt and hydrogen gas. Hello friends, in this video we will study how do metal carbonate and metal hydrogen carbonate react with acid. When metal carbonate react with acid, metal carbonate react with acid, they form salt, carbon dioxide and water. So example, Na2CO3, sodium carbonate is a metal carbonate, HCl, hydrochloric acid. When these two reacts with each other, product formed are salt, NaCl, sodium chloride, CO2, carbon dioxide, H2O, water. Then next, when acid react with metal hydrogen carbonate, they form salt plus water plus carbon dioxide. Now, see the example. Calcium hydrogen carbonate, CaHCO3, calcium hydrogen carbonate. When react with H2SO4, H2SO4 is acid. This is metal hydrogen carbonate. This is acid. When they react with each other, product form CaSO4, calcium sulfate. This is salt, carbon dioxide and water, H2O, water. Metal carbonate means when metal reacts with carbonate group, they form metal carbonate. Metal hydrogen carbonate means when metal reacts with hydrogen carbonate group, they form metal hydrogen carbonate. Already this thing you know. Hello friends, welcome back. In this video, I will explain how acids and bases react with each other. When acid react with base, the product formed are salt and water. And the reaction between acid and base is known as neutralization reaction. The general form of neutralization reaction is base plus acid. These are the reactants. Reaction happens, product form, salt plus water. C. NaOH is the base plus acid. HCl is the acid. These are the reactants. Salt, NaCl, sodium chloride is a salt, plus H2O is water. So these are the product form. Now, reaction of metallic oxide with acid. So metallic oxide, when metal reacts with oxygen, they form metallic oxide. And these metallic oxides, when reacts with acid, they form salt plus water. See the example. MgO, magnesium oxide, metal oxide, reacts with acid, hydrochloric acid, HCl. Product form MgCl2, magnesium chloride, salt, H2O, water. These are the products. Another example, copper oxide, when reacts with hydrochloric acid, this is metal oxide, reacts with hydrochloric acid, forms CuCl2, copper chloride, this is salt, and H2O is water. Now, next part is reaction of non-metallic oxide with base. Here, one thing to memorize. Non-metallic oxides behaves like acid. Non-metallic oxides are acidic in nature. So simple, base reacts with acid and form salt and water. See the reaction, HCl plus NaOH, acid plus base. Salt, water, NaCl, H2O, product form. Thank you for watching the video. If you like it, please do share it and subscribe channel for more such fruitful videos. You can call me for home tuition also. I will take home tuition for subjects mathematics, science and SST for classes 6 to 12. And if you have group of 3 to 4 students at your place, I will take tuition at your place for this group of 3 to 4 students. Thank you. Hello friends, welcome back. In this video, I will explain what do all acids and all bases have in common. Means what is the common in all acids and what is the common in all bases. All acids conduct electricity and all acids contains H plus ions when it is dissolved in water. All bases or some bases do not conduct electricity like glucose, alcohol, and some bases conduct electricity, sodium hydroxide. All bases contains OH minus ions when dissolved in water. Now, next part. What happens to an acid or base when it mix with water and form the solution? When acid added to water, it forms H plus and Cl minus ions. Again, H plus ions reacts with water and forms H3O plus ions. This H3O plus ion is called hydronium ion. So we can say that when acid reacts with water, hydronium ion or H plus ion are formed. What happens when base is dissolved in water? Now see, NaOH is the base, sodium hydroxide. dissolved in water H2O, Na plus and OH minus ion forms. Potassium hydroxide, when dissolved in water, it is a base, K plus and OH minus ions form. Here magnesium hydroxide, MgOH twice, dissolved in water, Mg2 plus and OH minus ions form. So we can conclude that bases generate hydroxide, that is OH minus ions in water. Now, point to remember, bases which are soluble in water are called alkalis. Bases which are soluble in water are called alkalis. Now, we'll study process of dilution. Mixing an acid or base with water results in decrease in the concentration of hydronium ion or hydroxide ion, OH minus ions per unit volume. Such a process is called dilution, and the acid or the base is said to be diluted. Meaning of this is mixing an acid with water results in decrease in the concentration of hydronium ion, H3O plus ion per unit volume. Such process is called dilution of acid. And in this case, we can say acid is diluted. Now, when mixing of base with water results in decrease in the hydroxide ion, OH minus ions per unit volume, such process is called dilution of base, and the base is said to be diluted. Thank you for watching the video. If you like it, please do share and subscribe channel for more such fruitful videos. Hello friends, in this video we will discuss how strong are acid or base solutions. Means how to measure whether solution of acid is strong or weak, whether the solution of base is strong or weak. Here, a scale for measuring hydrogen ion concentration in a solution is developed. That scale is called pH scale. In pH, P stands for potence and its meaning is power. Generally, scale has 0 to 14 numbers written like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13 and 14. Now, 0 means solution is strong acid. 14, solution is strong base. And 7 is solution is neutral. It's neither acidic nor basic. So a number decreases from 7. So acidic nature increasing. Acidic nature increasing means H plus ion concentration increases in this way. From 7 to 14, as number increases, basic nature increases. Means OH minus ion concentration increases. From 7, here H plus ion concentration increases because this side is acidic in nature and acidic nature increasing. From 7, here decrease in H plus ion concentration. So it is basic in nature. Based on the hydrogen ion concentration and hydroxide ion, OH minus ion concentration, acidic nature and basic nature is decided, and it is mentioned on this scale. This scale is called pH scale. Now, here I have prepared table as per activity 2.11. We have taken saliva before meal, saliva after meal. Here color of pH paper, and here approximate pH value, and here nature. See, saliva before meal, color of pH paper green, approximate pH value 6.8 to 7.4. So it is slightly acidic to basic. We can say it's a neutral. 7 is neutral. So it's slightly acidic, slightly basic. Saliva after meal, color of pH paper yellow green, pH value 5.8. 5.8 is less than 7, so it is acidic in nature. Lemon juice 2.2 pH value, acidic in nature. Colorless aerated drink 4 pH value, it's acidic. Carrot juice 6 pH value, acidic because less than 7. Coffee pH value 4.5, it is acidic. Tomato juice 4.3 pH value, acidic. Tap water 6 to 8.5, it is varied in nature. It may be slightly acidic or slightly basic. Sodium hydroxide NaOH, dark blue color, approximate pH value 14, it is basic, strong base. Hydrochloric acid, red in color, pH paper color red, approximate pH value 0. So 0 means acidic, strong acid. Now, pH of some common substances shown on pH paper. Here colors are rough guide. This is called pH paper. On pH paper 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 0 to 14 pH scale is written. Gastric juice pH value is 1.2. Lemon juice pH value is 2.2. Pure water and blood pH value is 7 or 7.4. Milk of magnesia pH value 10, and sodium hydroxide pH value 14. Here colors are just the guide. So this is the, see, pure water or blood has pH value 7 and slightly more than 7, slightly. So pure water and blood is neutral in nature. Now there are 4 combination happens, that is strong acid, weak acid, strong base and weak base. Strong acid, acid that give rise to more H plus ions when dissolved in water, then acid is called strong acid. Weak acid, when acid give rise to less H plus ions when dissolved in water, this is weak acid. Strong base, a base that give rise more OH minus ions. OH means hydroxide ions when dissolved in water. Weak base, the base that give rise to less OH minus ions, that is hydroxide ions when dissolved in water. then it is called weak base. Now, acid base reactions. So there are four combinations. When already we have studied, when acid reacts with base, salt and water is formed. But what is the nature of that salt? Based on the which acid or which base we have used. First combination, strong acid, strong base. When strong acid reacts with strong base, it forms salt water and it is neutral. When strong acid reacts with weak base, product form is of acidic nature. When weak acid reacts with strong base, product form is of basic nature. When weak acid reacts with weak base, product form may be acidic, may be basic, or may be neutral. So these are the four combinations for acid base reaction, and what is the result or what is the product or what is the nature of product formed after reaction is given here. General name of reaction is neutralization reaction. Acid base reaction is neutralization reaction. Now pair of acid and base. Strong acid, strong base pair, H2SO4 and NaOH. Strong acid, weak base, HCl and NH4OH. Weak acid and strong base, CH3COOH plus NaOH. Weak acid and weak base, CH3COOH and NH4OH. NH4OH is ammonium hydroxide. CH3COOH is acetic acid. HCl is hydrochloric acid. H2SO4 is sulfuric acid. NaOH is sodium hydroxide. So whatever I have explained, same thing is nature. Nature of acid base, example, and its pH of solution at the end point. Means here what is the nature of product formed. So here same thing I have explained in this figure. Now, importance of pH in everyday life. pH of our body works in the range of 7 to 7.8. When pH of rainwater is less than 5.6, it is called acid rain. When acid rain flows into the river, it lowers the pH of the river water. Now, acid in other planets, the atmosphere of Venus is made up of thick white and yellowish clouds of sulfuric acid. Now, ideal soil pH for the growth of plant should be in between 6 to 7. pH in our digestive system. In stomach, pH value is 1 to 3, acidic. Small and large intestine, pH value is 6 to 8. Now, pH change as the cause of tooth decay. Tooth decay starts when pH of the mouth is lower than 5.5. Tooth enamel made up of calcium hydroxyapatite, a crystalline form of calcium phosphate, is the hardest substance in the body. It does not dissolve in water, but it corroded when pH in the mouth is below 5.5, that is acidic. Bacteria present in the mouth produces acid by degradation of sugar and food particles remaining in the mouth after eating, and tooth decay occurs. To prevent this, best way is to clean the mouth after eating food. Using toothpastes, which are generally basic in nature, for cleaning the teeth can neutralize the excess acid and prevent the tooth decay. Here we are using toothpaste to clean the teeth. Why? Because toothpastes are basic in nature. When base reacts with acid, salt is formed, salt and water is formed. So it will prevent tooth decay. Now, some naturally occurring acids, vinegar, source, acid is acetic acid, orange, we have citric acid, tamarind, we have tartaric acid, tomato, oxalic acid, sour milk, that is curd, lactic acid, lemon, citric acid, ant sting, methanoic acid, nettle sing, methanoic acid. These are the some natural sources and acid. Which acid is present in natural sources is shown in this table. Thank you for watching the video. If you like it, please do share it and subscribe channel for more such fruitful videos. Hello friends, welcome back. In this video, we will learn more about salts. As you know, when acid reacts with base, salts are formed. Now, in the table shown on the screen, shows two columns. In first column, salts and their chemical formula are written. In second column, from which acid and base they are formed are written. First, potassium sulfate K2SO4 formed from H2SO4 and KOH. This is acid, this is base. Sodium sulfate Na2SO4 formed from H2SO4 and NaOH. Calcium sulfate CaSO4 formed from H2SO4 and CaCO3. Magnesium sulfate MgSO4 formed from H2SO4 and MgOH twice. Copper sulfate CuSO4 formed from H2SO4 and CuOH twice. Sodium chloride NaCl formed from HCl and NaOH. Sodium nitrate NaNO3 formed from HNO3 and NaOH. Sodium carbonate Na2CO3 formed from H2CO3 and NaOH. Ammonium chloride NH4Cl formed from HCl and NH4OH. Here, first one is the acid, second one is the base. Now, there are different families of salt. based on their chemical formula. First family of salt is family of sodium salt. Examples are Na2SO4, NaCl, NaNO3, Na2CO3. Now, second family is family of sulfate salts. K2SO4, Na2SO4, CaSO4, MgSO4, CuSO4. Then third family is family of chloride salts, NaCl and KCl. Now, here in this table, I have shown pH value for different salts. pH value of solution or salt depends upon which acid and which base is used for the formation of that salt. As already we know, salts of strong acid and strong base are neutral with pH value 7. If strong acid reacts with strong base, whatever salt formed is of neutral nature. So here sodium chloride, acid used HCl, base used NaOH, both are strong, so pH value is 7. Sodium chloride pH value is 7. Potassium nitrate pH value is 7, formed from HNO3 and KOH. These are strong acid, strong base. Aluminium chloride pH value 7, formed from HCl and AlOH thrice. Zinc sulfate pH value is 7, H2SO4 and ZnOH twice. Now, when salts formed from the reaction of strong acid and weak base, then these salts are acidic in nature with pH value less than 7. Example is copper sulfate. pH value is less than 7, found from H2SO4 and CuOH twice. Now, when salts are formed from the reaction of strong base and weak acid, these salts are basic in nature. Their pH value is more than 7. Example, sodium acetate is a salt. pH value is greater than 7. It is formed from the reaction of CH3COOH, acetic acid, and NaOH, sodium hydroxide. Because base is strong, this acid is weak. Now, sodium carbonate salt is formed from the acid H2CO3 and base NaOH. pH value of sodium carbonate greater than 7. Sodium hydrogen carbonate pH value is greater than 7. It is formed from H2CO3 and NaOH. H2CO3 hydrogen carbonate. It's a weak acid. NaOH is a strong base. So here table indicates pH value of salts based on the how these salts are formed. Strong acid, strong base reaction, strong acid, weak base reaction, weak acid, strong base reaction. Yes. Next, chemicals from the common salt. As we know, when hydrochloric acid reacts with sodium hydroxide, a salt formed is sodium chloride, and this sodium chloride is called as common salt. Deposits of solid salts are also found in several parts of the world. These large crystals are often brown due to impurities. and these are called rock salt. Beds of rock salt were formed when seas of bygone ages dried up. Rock salt is mined like coal. When sea dried up, then these rock salts are formed. Now, common salt is a raw material, and the salts or the chemicals formed from the common salt are sodium hydroxide, baking soda, washing soda, and bleaching powder. Now, one by one, we'll see the reaction, how it is formed. Sodium hydroxide, it is caustic soda. We can say caustic soda. When electricity is passed through an aqueous solution of sodium chloride, here aqueous solution of sodium chloride is called brine. It decomposes to form sodium hydroxide. The process is called chlor-alkali process because the product formed is chlor, and it is chlor for chlorine and alkali for sodium hydroxide. So reaction is NaCl, aqueous solution, with water forms, arrow means reaction happens, forms NaOH, sodium hydroxide, caustic soda, plus chlorine gas, plus H2 gas. These gases are evolved. So that's why this reaction is called chlor-alkali reaction or chlor-alkali process. Chlor for chlorine gas and alkali for sodium hydroxide. That is chlor-alkali process. Now, bleaching powder. When calcium hydroxide and chlorine gas reacts with each other, it forms CaClO twice, that is bleaching powder. This is the name of this compound, CaClO twice, bleaching powder, and other products formed are CaCl2, calcium chloride plus water. This way bleaching powder is formed. Now, uses of bleaching powder. For bleaching cotton and linen in the textile industry, for bleaching wood pulp in paper factories, and for bleaching washed clothes in laundry, bleaching powder is used. Bleaching powder is used as an oxidizing agent in many chemical industries. Bleaching powder is also used to make drinking water free from germs. Now, how baking soda is formed? When NaCl plus water plus carbon dioxide plus NH3 ammonia reacts with each other, NH4Cl, ammonium chloride, and NaHCO3, sodium hydrogen carbonates are formed. This sodium hydrogen carbonate NaHCO3 is called baking soda. Now, when sodium hydrogen carbonate NaHCO3 decomposes means heated. When this sodium hydrogen carbonate heated, Na2CO3, sodium carbonate plus water plus carbon dioxide is formed. So this reaction is decomposition reaction. Already we have studied in chapter number 1 type of reaction. Now uses of baking soda for making baking powder. Baking soda is used, which is baking powder is a mixture of baking soda, sodium hydrogen carbonate and mild edible acid such as tartaric acid. When baking powder is heated or mixed in water, this reaction is happen. NaHCO3 plus water means H plus ion, reaction happens. Carbon dioxide plus water plus sodium salt of acid is formed. Carbon dioxide produced during the reaction can cause bread or cake to rise, making them soft and spongy. Sodium hydrogen carbonate is also an ingredient in antacids. Being alkaline, it neutralizes excess acid in the stomach and provides relief. It is also used in soda acid fire extinguishers. So these are the uses of baking soda. Now washing soda. Another chemical that can be obtained from sodium chloride is Na2CO3 10H2O. Washing soda. We have seen above that sodium carbonate can be obtained by heating baking soda. Recrystallization of sodium carbonate gives washing soda. It is also basic salt. It is recrystallization. Recrystallization means forming crystals. Forming crystals means the compound is having hydrated water molecules in them. So see, sodium carbonate Na2CO3 plus 10H2O added. These two are reactants. Chemical reaction happens. Product form Na2CO3 10H2O. This product is crystalline form and chemical name is sodium carbonate decahydrate. Sodium carbonate decahydrate. It has in crystallization nature. Crystals are formed. Crystals means they have or the compound having hydrated water molecule in them. Now, uses of washing soda. First, sodium carbonate, that is washing soda, is used in glass, soap and paper industries. Washing soda is used in the manufacture of sodium compound such as borax. Sodium carbonate, that is washing soda, can be used as a cleaning agent for domestic purposes. Washing soda or sodium carbonate is used for removing permanent hardness of water. These are the uses of washing soda. Hello friends, welcome back. Here one phenomenon is there, water of crystallization. Water of crystallization is the fixed number of water molecules present in 1 unit of salt. If 1 unit of salt is there, the fixed water molecules present in that, they are called water of crystallization. Now see the example. Hydrated copper sulfate. Hydrated copper sulfate, CuSO4 5H2O. Sodium carbonate decahydrate Na2CO3 10H2O. Gypsum CaSO4 2H2O. Now see the reaction. CaSO4 2H2O gypsum when heated at 373 degree Kelvin. CaSO4 half H2O. This compound is called plaster of Paris, and 3 by 2 water molecule is removed from the CaSO4 2H2O, that is from the gypsum. By heating, 3 by 2 H2O molecules are removed and the compound formed is CaSO4 half H2O, that is plaster of Paris. When plaster of Paris reacts with water, it forms calcium sulfate 2H2O, that is gypsum. CaSO4 2H2O. This is crystallization form, crystal form, and this water is water of crystallization. That is, this is the formula for gypsum. Now, same thing here is written, whatever I have explained. Water of crystallization is the fixed number of water molecules present in one formula unit of salt. 5 water molecules are present in one formula unit of copper sulfate. Chemical formula for hydrated copper sulfate is CuSO4 5H2O. For one formula unit of salt contains 5 water molecules. Now, you would be able to answer the question whether molecule of Na2CO3 10H2O is wet or not. It's not wet because it is hydrated. One other salt which possesses water of crystallization is gypsum. It has 2 water molecules as water of crystallization. It has chemical formula CaSO4 2H2O. On heating gypsum, same reaction I have explained. It loses water molecule and becomes calcium sulfate hemihydrate, CaSO4 half H2O, and this is called plaster of Paris. The substance which doctors uses as plaster for supporting fractured bones in the right position. Plaster of Paris is a white powder, and on mixing with water it changes to gypsum once again, giving a hard solid mass. Plaster of Paris is a white powder. When it mixes with water, it changes to gypsum, which is hard solid mass. That's why doctors are used to support fractured bone when doing plastering for it. Now, why is calcium sulfate hemihydrate is called plaster of Paris? Plaster of Paris gets its name from the large gypsum deposit in Montmartre. Deposits in Montmartre in Paris. We know that plaster of Paris, which is chemically calcium sulfate hemihydrate, is obtained by heating gypsum. So, the origin of the name plaster of Paris is the fact that the source material gypsum is found in large deposits at Montmartre in Paris, and because of this it is called plaster of Paris. Chemically it is calcium sulfate hemihydrate. Thank you for watching the video. If you like it, please do share it and subscribe channel for more such fruitful videos. You can call me for home tuition. The details or contact details are shown on the screen. I am taking home tuition for class 6 to 10, all the boards, Subject taught mathematics, science, SST. Teaching methods are as per syllabus and as per exam pattern and as per new education policy. If you have a group of 3 to 4 students at your place, you can call me for group tuition also at your place. Thank you.